Hi, I'm an Untitled an 8th grader from John F. Kennedy Middle School. In this video, I want to talk about how to find the continuity of a function graphically. So let's get started. Let's start off by talking about what continuity is. So it's defined as, since we're talking about curves in calculus, the definition is in terms of curved. So a curve is continuous when it has no holes, breaks, or asymptotes. Now I will explain what holes and breaks are in just a few moments, but I hope you guys are familiar with the terms asymptotes from algebra and other math classes you might have taken. So that's the definition of what continuity is. Now what we're going to look at is the steps, or like the things you need to look at before confirming whether the graph is continuous or not. First thing we're going to do, while looking at the function, you have to look at point C and see if it's defined, where C is the point you're looking at. Second thing, we're going to find out the limit of f of x function, f of x, as x approaches to c exists. Third step, the limit of f of x as x approaches to c is equal to f of c. Now, it may seem a little more confusing to you right now, but once I show it to you on these graphs over here, I hope you guys will understand. Okay, so here's our graph number 1. Let's start following the steps. Point f of c is defined. Let's see if that's true. So our point C is here on the function, but it is not defined because there's a hole. And this is what I meant by holes in the definition. Holes are basically the point where it is undefined at that one point. Whereas you can see over here, it is not defined. But now let's just follow the other steps and see what we can do. Limit, because we already know it's not continuous, but we can just follow the other steps just so you guys can get a feel for how it is. Limit of f of x exists as x approaches to c. So let's see, what does that mean? The limit, as I went over in my other videos, is when the two sides come really, really close to that one point, but doesn't quite ever reach that one point. So this side is coming, approaching c, gets really, really close, but never is c. This side's doing the same thing. So actually the limit f of x as x approaches c does exist. So we can see this is good in this first question. Now limit of f of x as x approaches c equals f of c. Well, f of c is not really defined, so you can't really do it. But now, another thing we're going to have to go over while doing this are discontinuities. Now, the type of discontinuity this is called a removable discontinuity because of the fact that if you were to remove this and make it an actual value, it becomes a continuous function because everything will then be equal. So removable discontinuity basically means if you were to take out the undefined point and put in a value which is actually defined, it will work. So this is not continuous. And it's writing the whole word continuous. But has a removable discontinuity. A removable discontinuity. So I guess that's going to be our first type of discontinuity that you're going to learn about in this video. Here's our second graph. Okay, let's follow the steps. Point f of c is defined. Let's see. It is defined. I know this will confuse you guys because there's one undefined point and one defined point. But it is defined because at least one of the points are defined. So step 1 is right. Limit of f of x as x approaches to c. So if we were to take the limit of this function from the left side, you would see it's approaching this, let's say this is 1 and this is 2, okay, y values. So this is approaching 1 and this is approaching 2. So this does not exactly equal, the limits don't exist because they're heading towards different points, not the exact same point. So the limit doesn't exist. So in this one, the point is defined, but the limit does not exist. And the last thing, if the point is not defined, then it cannot really exist. So this one is also a type of discontinuity actually, because it's called a jump discontinuity, because if you were to jump this up to here, it would automatically be continuous. I hope you guys kind of understood what I'm trying to say there. No, I wasn't talking completely clear, but so this is also not continuous. It is not continuous. Has a jump discontinuity. Has a jump discontinuity. Okay, so let me try going over that again because I don't think I made myself really clear there. So if this is my first half of the function and this is the other half, and they both are heading towards different points, so the limit automatically doesn't exist. But jump discontinuity basically means that if we were to jump this one up here, the limit would first of all exist, and second of all, it would be continuous. So that's what I kind of meant over there by, that's what a jump discontinuity is. Next graph. Our next graph, we have an asymptote at point C, so it's never gonna, it has an asymptote, so it's gonna head towards infinity, but they're never gonna touch. Now, it says point f of c is defined. We don't really have a point f of c right now, but so we can't really say it's defined. But if I were to do this, if I were to just add a point here, would it be defined? Yeah, definitely, it would be completely defined. But for this example, I didn't have a point there, so it's not defined. Does the limit exist? Actually, yeah, it does, because even though this point will always be undefined as heading towards infinity, these two are going to get really, really, really close to the exact same point all the way up there somewhere. So the limit exists, but this is not happening again. So, what is this called? An infinite discontinuity. It's called an infinite discontinuity. It's pretty self-explanatory because of the fact that this is going to head on to infinity and it's not going to come to an end. So, I'm just going to say not continuous and has a infinite discontinuity. Okay, now here's our last graph. Is our point f of c defined? Oops, forgot to make a point c out. Is it defined? Definitely, closed circle. Everything's going well right now. It's completely defined. Does the limit f of x as x approaches c exist? Yeah, because if you're taking it from the left side, it's heading towards this point C. If you're coming from the right side, it's heading towards point C. So it is indeed, the limit does indeed exist. And if I were to take the limit of it, and we have point C which is defined, would they be equal? Yeah, completely. Because these two are heading towards the same point. That point is point C, so it is definitely going to be defined. So this is actually our only function that's going to be continuous. So I hope this video helped you guys understand how to find continuity graphically, and probably in some future video I'll also go over how to find it from equations and expressions. But I hope this video helped you, and thank you for watching. Please like and subscribe. Bye!